This video is recorded to help my students to understand how to test a claim about two proportions. First, we need to understand all those notation and the requirement. The requirements: 1. We have proportions from two independent sample random samples. 2. Each of the two samples, the number of success is at least 5 and the number of failure is at least 5. Then we need to understand all those notations mean. P1 hat is the proportion from sample 1. P2 hat is the proportion from sample 2. Then P1 and P2 are the proportion from the population 1 and the proportion from population 2. Then this P bar is x1 plus x2 over n1 plus n2. You can say x1 is the success number in sample 1, n1 is sample 1's size, x2 is the success number in sample 2, and n2 is the sample 2's size. Then q bar is 1 minus p bar. So then the confidence interval for the difference of the two population proportion P1 minus P2 will be given by this: P hat minus P1 hat minus P2 hat. So P1 hat we already say is the proportion from sample 1, P2 hat is the proportion from sample 2. And this E is margin of error. Margin of error get by this formula is Z alpha over 2. Again, the alpha is significance level. If you want to construct a 95% confidence interval, then alpha is 1 minus 0.95, which is 5%. So the square root of P1 hat multiplied Q1 hat divided by N1. So this Q1 hat is 1 minus P1 hat. Then this P2 hat multiplied Q2 hat divided by N2. Here Q2 hat is 1 minus P2 hat. Okay, so after you understand all those, then you just need to apply the data they give to you in any problem to these formulas. Then you do it slowly by using Excel to the calculation. Let's say example. A study was conducted to determine the proportion of people who dream in black and white instead of color. Among 294 people over the age of 55, 67 dream in black and white, and among 288 people under the age of 25, 11 dream in black and white. Use a 0.05 significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. So we know we have two populations. One population is the people over the age of 55. Another is the people under the age of 25. So you have two populations. Then we have two samples. One sample is 294 people random draw from this population 1, which are the people of the age over 55. Another sample is 288 people draw from the population of the people under the age of 25. So we list all those things we know. We also need to list the null hypothesis and the alternative hypothesis. Alternative hypothesis is the claim that the proportion in population 1 is greater than the proportion in population 2. So this is your alternative hypothesis. Then your null hypothesis is opposite. So we have equal signs here. So we use P1 equal P2. Okay. So then N1 is the sample 1's size, which is 294. N2 is sample 2's size, which is 288. X1 is the success in sample 1, which is 67 people dream in black and white. X2 is the success for the people dream in black and white from the sample 2, which are the people under age of 25. Now, let's say all those two conditions are satisfied, right? So you have at least 5 success and at least 5 failure, okay? So let's say the p hat, you click on the formula, p hat will be the success in sample 1 divided by the sample 1 size. Okay, then the p2 hat is the success in sample 2 divided by sample 2 size. Okay, then p bar. Now p bar uses this formula, then you will say is sample 1. Actually, I should use the cell number. Probably it's better to use cell number, then you can use this to calculate other problem. So cell number, which is x1, which is in B11, C11, I'm sorry, C11 plus C12 divided by N1, which is C9 plus C10. Okay, that's your P bar. So Q bar is just simply 1 minus P bar. Okay, then we need to calculate Z. Notice Z will use this formula. In this formula, notice P1 minus P2 will equal 0. This is based on the null hypothesis, P1 equal P2. Okay, so we simply just P1 hat minus P2 hat divided square root of this thing. So if you click on the formula, you can say, here's how you do it. P1 hat is in C14, P2 hat is in C15. Notice, make sure you group them in parentheses, then divide by square root of P bar multiplied Q bar, which is C17 multiplied C18 divided by N1, which is in C9, then plus P bar multiplied Q bar, which is C17 multiplied C18 divided by N2, which is in C10. Okay, hit indicate. That's your z-score. Then based on this z-score, you need to calculate the p-value. So the p-value is 1 minus normal distribution, standard distribution. Then you give his z-score, right? Accumulative. Then use 1 minus it. This give you the right tail area. How that, because we need to calculate the right tail. How do you know? Because this automatic hypothesis is greater than P1, greater than P2. So we use right tail. Okay. Now this p-value is very, very small. Small p-value means that we reject null hypothesis. Okay. You reject null hypothesis, which means we have strong sufficient statistical evidence to support the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Now, your book also asks you to do it by use confidence interval method. To construct a confidence interval, we need to first calculate those margin of error. So significance level suppose is 1%. Here we did not include the problem. Here is we try to construct 10%, I mean 90% confidence interval with in this problem. Okay. So if you alpha, since 90% confidence interval, so your alpha is 0.1, which is 1 minus 0.9. So I calculate z alpha over 2, which normal distribution inverse 1 minus alpha over 2. Okay, that's your z alpha over 2. Then your margin of error will be z alpha over 2 multiply this value. So this value will be P1 hat, which is in C14. Then Q1 hat is 1 minus P1 hat, then divide by N1, which is in C9. Then the same thing for P2 hat, which is C15, multiply Q2 hat, which is 1 minus C15, then you divide by N2, which is C10. Okay. After you got this margin of error, then your upper limit of the confidence interval is P1 hat minus P2 hat plus the margin of error, right? So C14 is P1 hat minus C15, P2 hat, then plus margin of error. Then the lower limit will be this P1 hat minus P2 hat minus the margin of error. Now, how do you interpret the result? Look at this confidence interval. Is a confidence interval for P1 minus P2. Since this confidence interval doesn't include 0 inside, which means we can know P1 equal P2, this null hypothesis will not be true, right? So P1 equal P2 will not be true. More likely P1 will greater than P2, okay? Because P1 minus P2 will locate in this confidence interval, right? So since it's all positive, so we have confidence to say that P1 minus P2 is greater than 0, more likely support the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. So if you have any questions, please give me an email.